of our lesson. Okay, so yesterday we stopped on, we're looking at capillarity. Oh, that was about capillarity. But the other time, we looked at something else. We looked at, if you check here, we looked at the variation of day and atmospheric temperature. So we looked at what causes the variation of the atmospheric temperature. And we named different factors that give rise to the variation of that temperature or the change in temperature around us or in the atmosphere. And we said that one of those two things, one was about the altitude. The altitude contributes to the daily change in temperature or the atmospheric temperature, because we know that the higher you go, the cooler it becomes. Why is it cool at a high altitude? We say that at a high altitude, there are less air molecules, and these air molecules, they have less kinetic energy. So it means that their temperature also reduces with their kinetic energy. We looked at what we call the diurnal change, and the diurnal change is the difference between the temperature of the day and the temperature of the night. So we say that during day, the temperature is quite high compared during night hours. And we say that sometimes the day becomes so hot or becomes so warm. The reason is that there is what we call the surface radiation. This surface radiation is due to the heat that is emitted from the ground. So it means that the ground absorbs heat during day and it emits it also during day. So that's what we call the surface radiation, the heat that is lost from the land or that is lost from the ground. And this causes the warming. And there is what we call also the solar heat. This is the heat that comes from the sun. So in most cases, when the surface radiation, exceeds the solar radiation, then it means that that day is going to be very, very hot, very, very hot, very, very hot. So you have to know that during day also we have what we call, during night hours, we have also what we call the solar radiation. So during night hours, the solar radiation ceases or it reduces, and the surface radiation for it continues. Because as the land absorbs heat during day, it continues to lose the heat even throughout the night hours. So even if the sun has gone away, but the land will continue to lose the heat because the sun has gone away. So this is what we call the surface radiation from the land that continues. And this surface radiation continues and cools up the surface. So it means that during night hours, the land loses more heat and it becomes very cold and very cold. So when this cooling continues after sunrise, after the solar radiation again exceeds the terrestrial radiation, and at this time the minimum temperatures, they are saying the minimum temperatures are usually occur after the sunrise. So normally when there is sunrise, then the solar radiation now starts again, and then the temperature continues to rise slowly by slowly as the sun goes up. When it goes down, the temperature reduces. Okay, so there are things that I told you that contribute to the atmospheric temperature. We talked about the humidity. We talked about the average temperature throughout the day. We talked about the regime of winds and also the proximity to water bodies. So you know that areas which are around the water bodies experience a lot of winds, and normally they are cold. That's why people want to go to the beach, people want to go to the shores of the lake to have that kind of cool wind or cool atmosphere around the showers blowing towards them, and they feel so nice and cool and cold. So it means that around those areas that have water bodies, the temperatures are quite low compared to areas that do not have water bodies. And also I talked about the humidity, that during night hours or during morning hours, there is humidity. The humidity is high, and that's the reason why the temperature falls during the morning hours or during night hours due to humidity. So this one also contributes to the production of the production of fog or mist in the atmosphere. So because of low temperatures, we shall have mist. We shall have mist in air during night hours and also during morning hours. The reason is that air has now condensed into small water bubbles that form mist or form fog. I don't know whether you have ever seen fog, but I think it has occurred once in my lifetime. I think when I was still around 7 years. And you cannot see what is next. You cannot see something that is next to you after, let's say, 1 meter from you. You can't see anything. You just see only white things like fog. It's fog, actually. Fog, when it's a lot of mist around you. So you can't see anything beyond you 1 meter. You need to, or you need to use nothing you can use, but it is due to the formation of the fog within the atmosphere. So whenever fog is formed, you have to know that the temperatures are very low. They are very low. If fog is there and there is a drought, then I doubt that kind of let me say system or condition that is there. But in most cases, when fog is there, the day is very cold. It's very cold. It's very cold. For those people who have been out, like Sean, have you been out?
Yes.
Which place?
I don't remember.
Okay, Shona, but in Kenya, there is no, I don't know whether fog is there. In Congo, if you have been to Congo, Rwanda, I don't know, but what you have to know is that, anyway, still that is out, but fog normally occurs in those areas that have very low temperatures, minus. Minus. Okay. All right, so let us proceed. So let us look at today's chapter. Today we are going to look at heat transfers. So in our books we write so we have Dakia and Pav, good morning, and Ruth, also good morning, Bridget, good morning. Sure. So let us look at heat transfers. So in our books, let us write heat transfers. Heat transfer. Heat transfer. And what do you understand by the term heat transfer? Let me ask you. What do you understand by the term heat transfer? This is something that you have already studied. Yes? Who knows heat transfer? What's heat transfer? What do you understand by the term heat transfer? Or what comes to your mind if someone talks about heat and then transfer? Heat and then transfer. What comes to your mind? Yes, Pav. You have put up your... you have not put up, but yes?
Heat transfer, as it is called heat transfer, I think it is the transfer of heat energy through objects.
The transfer of heat through objects.
Yes.
The transfer of heat through objects, that's correct. Who can add on something there? Bridget? Bridget? The transfer of heat through objects. Now, do you see this picture that we are having here? This picture which is here. This gentleman is touching this side. Is this side very hot? Or this side is the one which is hot? Which side is hot? The one which is here or the one which is here? The one where he's touching or the one next to the plate?
The one next to the plate.
So now, what's heat transfer? What's heat transfer? What will happen if at all he removes the water and then leaves this can or this container or this saucepan on this plate for some time? What will happen to the can?
Yes, I've received. Let me ask you this.
What will happen? Dakia. Dakia?
Yes.
Yeah, okay. What will happen? Will the saucepan remain very cold?
No.
No.
So what will happen to the saucepan? Suppose mom is cooking and then she leaves the saucepan on fire without putting anything there. What will happen to it?
The saucepan will get very hot.
It will be very hot. It will be
Yeah.
very hot. Okay, so now let me give you another scenario. Suppose you get a metallic bar. A metallic bar. Suppose this is a metallic bar. And you put it where this fire is and you hold it there. You put it in fire and you hold it. What will happen after some time?
It will turn red hot.
And you remain touching it like this.
No, we'll suddenly leave it.
Hey. It will do what?
We will suddenly leave it.
It will suddenly do what? It will suddenly become hot, isn't it? So after some time, it will become hot. Suppose I put it in fire. Suppose it's a candle burning and you put a nail on that flame of a candle for some time, like 3 minutes, and then afterwards you remove it. And then you touch this other side where the fire was. It will be very what? It will be very hot, isn't it?
Yes.
Yeah.
But this other side where you're touching, it will be cold, isn't it?
Yes.
It won't be that
But
cold.
now if I leave that nail there on the flame of fire for something like 1 hour or beyond that, what will happen to the whole to the whole of the nail?
It will be
It will
hot.
become
It will be
Very
what?
hot.
It will be
hot.
hot.
It will be very hot. So now, what is heat transfer? I will have to know this one. Yes? What's heat transfer? So what do you understand by the term heat transfer? Yes?
Movement of heat energy through objects which causes in change of temperature.
Which causes change temperature, okay? So it means that there is a point that has a high temperature and another point does not have a high temperature, or another point has a low temperature, isn't it? So when you put the nail in fire, the heat will be transferred from this point that is hot. Are we together? From the point here, from this point that is hot to the point that is not what? That is not hot. So heat will be transferred from a point that has a high temperature to a point that has a low temperature. Are we together?
Yes.
So heat transfer, we are looking at the transfer of heat, or the movement of heat energy from a region of high temperature to a region of low temperature. Are we together? So that's what we call heat transfer. The movement of heat energy from a region of high temperature to a region of low temperature. Are we together?
Yes.
Okay. Dakia, are we together?
Yes.
Okay. So let us proceed. So in this chapter, we are going to learn about different types of heat transfer, and they are three. They are three types. Who can give me those three types? One, Pav. One,
Induction.
conduction. Bridget. Bridget. Okay, Sean.
Radiation.
Radiation. And Ruth. Ruth. Yeah?
Convection.
Convection. So they are here. So we have conduction, convection, and radiation. Those are the three types of heat transfers. And we are going to understand how the heat energy is transferred from the region of high temperature to the region of low temperature in all those three states, in all those three types, in all of those three types. In conduction, how is heat transferred? In convection, how is heat transferred? And also in radiation, how is heat transferred? We shall also be able to understand how particles behave in conduction, in convection, and radiation when the heat is moving from a region of high temperature to a region of low temperature. We shall see the behavior of the molecules or the behavior of the particles. We shall also see what causes the sea to be cold, or the sea breeze, and also what causes the land to be cold, or the land breeze. We shall also look at the absorbers of heat. What are the absorbers of heat? And what are the emitters of heat? We have seen black things can absorb. If you put on a black sweater when it is very hot, you will not be of the same, you will not have the same condition or the same heat on your body compared to someone who's putting on a light white sweater. Okay, so something that is black and something that is white or shiny, all of them have different properties when it comes to heat. So some are good absorbers, others are good emitters, others are bad absorbers, others are bad emitters. So we shall see all that. We shall also see the greenhouse effect. If you know what the greenhouse effect is, normally you have seen people having flowers. They are having flowers. They are having plants, tomatoes in the greenhouse, in the house made out of glass. That is the greenhouse. So we shall see the greenhouse effect. So we compare that greenhouse effect to greenhouse effect that happens around the earth. And this greenhouse effect that happens around the earth contributes to global warming, and we shall see all that. So with our introduction here, they have said that we have noticed that when you put a cold metal teaspoon into hot cup of tea, the teaspoon's handle warms up after a while. Have you ever wondered why this warmth moved from the hot tea to the cold teaspoons handle? Have you ever wondered? Some of you just do the things and then you find all of a sudden the spoon is hot, isn't it? So have you ever wondered why the heat moves from the hot tea up to the teaspoon's handle? Why do we feel warm when we are cooking or ironing? Yeah? Ruth, why do you feel warm when you
Yes,
are cooking? Do you know how to cook?
yes,
Yeah?
yes.
You know how to cook? Okay.
Yes,
What do you cook best? Is it tea? Yeah?
yes,
Is it tea?
yes.
Okay. Your best dish is tea. Okay. Okay, so if you know how to cook, then during your procedures of cooking, you find that you become very warm when you are cooking, or you become very warm when you are ironing. Why? There is a certain heat transfer. There is heat that is transferred from the source of heat to your body, and through a certain heat transfer, either it is conduction, or it is convection, or it is radiation. So we shall see that. When you stand near fire, some of you like standing near fire. When you go outside camping, you go somewhere and you are camping, and then they bring firewood, and then they burn that firewood. So they put a heap of firewood and they start burning it, and you want to surround that fire because the fire is giving you some warmth. Do you know how the heat is transferred from the firewood that is burning to you, to your body? Do you know how it is transferred? Or do you know how
Yes.
it is transferred from the sun to your body? Do you know? So all
Yes.
that is what we are going to cover, and this should help you to understand. So, I say that when two or places are different temperatures, when two bodies or two places are at different temperatures, heat energy flows from the hotter body or place to a colder one. And in this chapter, we learn how heat is transferred from one body or place to another, and how heat transfer is useful in our daily life. So let us write first the definition of heat transfer, and we say that is the what? What's heat transfer?
It's a
What's heat
movement.
transfer, members?
Heat transfer is the movement of heat energy from a region of high temperature to a region of low temperature.
Is the movement of heat energy from a region or point. You can say from a region of high temperature, a region of
Low temperature.
low temperature. By conduction, convection, or radiation. So that's the definition of heat transfer, and you should get to know how heat is transferred. So we are going to look at these methods of heat transfer. So, right? Methods. Okay. Have you written methods?
Yes.
Okay. Methods of heat transfer. Methods of transfer. So there are three methods of heat transfer, and we are going to look at them. But here, you should know that before we look at the methods of heat transfer, you should note something. before we look at the methods of heat transfer, you should note something. That this heat, when heat is transferred, normally it is transferred from a place or body at a high temperature to a body of low temperature. So during heat, to say that heat is transferred from a body or place of high temperature to a body or place of low what? Low temperature. Okay. So we are going to look at those methods, but let us look at how do we identify those those three methods. Now, I want you to look at these pictures which are here, okay? I want you to look at these pictures which are here. And we are going to answer these questions. This one is going to be just our discussion here. We are not going to write anything here, but it's going to be our discussion. Now, let us look at picture number 1. This is picture number 1.
Yes.
Which kind of heat transfer is taking place there, if you may? Have you ever seen what is happening, first of all, in picture 1 here? In picture 1, what is happening?
Yeah.
You put up your hand if you want to speak. Yes, Bridget.
Two children are standing near fire.
Children are standing near what? Near fire. I think we can, let me zoom in if you can't see that. So that is picture 1. Children are standing near fire there. How do you think heat is transferred from the fire to their bodies? How do you think heat is transferred?
Through convection.
Through convection. How is heat transferred through convection? Let me go deep there. Okay, Pav, yes, Pav. Shoni, you're right, through convection, but how is it happening?
It's through radiation.
It is through radiation. Okay, through radiation. Now, what we are going to do is that everyone has his or her own answer. So with that, you note down your answer, and then when we look at the definitions of radiation, conduction, and convection, you get to know what is correct. So Pav is saying radiation, Sean is saying convection. So radiation and convection. Okay? Yeah. Both of you, you're right. You're right. Okay. Now let us go to image 2. What is happening in image 2?
A saucepan.
A saucepan is on fire.
The saucepan. Do you think the saucepan is empty?
No.
There is what?
That's what beans.
Cows.
There is what?
Maybe it is beans.
There are
Water.
some things. There is food. Okay. Suppose in the saucepan there is water. Let us suppose there is water. How does the heat from the fire reach the water in the saucepan? Yes, Sean.
Through radiation.
Through radiation. Okay, through radiation. Why do you say radiation?
I just think because I see fire comes from down there, and I just think it's radiation.
Okay, you just see the fire there going to the saucepan, and you just think it's radiation. Okay. Who else has another answer? How does fire reach to the water in the saucepan? Dakia. Dakia?
Yes.
How does fire reach the water in the saucepan?
Conduction.
Through conduction. Why do you say conduction?
I'm just guessing.
You're just guessing because they are free. So another person is going to tell me through convection. Bob, is it so?
I think it is conduction because first of all, the heat needs to, touch the metallic saucepan, which is a solid. So convection is going to first take place in order to make the water heat up.
Okay, so through convection, through conduction and convection. Okay. Good. So fire first goes to the saucepan and then it goes to the water, isn't it? That's what we are saying. All right, so let us go to image number 3. Image number 3. What do you think is happening? What is here in image number 3?
A candle burning.
Yes, Pav.
A candle is burning.
The candle is
lit
burning. It is lit and it is burning, isn't it?
Yes.
Why do you think this candle is melting? Or why does this candle that is burning, why is it melting? Yes, Pav.
That's due to the heat, which is making it melt, making the wax, the solid wax melt for liquid. Okay,
so the heat is absorbed by the wax and is making the wax to melt. Good.
Yes.
Good. Any other answer to that? Ruth? Any other answer to that? Why do you think a lit candle melts? Okay, do you agree with Pav that the heat is absorbed by the wax and the wax is now melting?
Yes.
Okay. All right, so all your answers are correct about that. But maybe something here about radiation that Pav gave us, that the water receives the heat through radiation. We shall find out why that one may not be correct. And also here, this cannot be through conduction. It can be through convection and radiation. We shall see why conduction does not apply in image 1, and we shall see why radiation does not apply in image 2, and also, hey, here you gave me correct answers. All right, so let us proceed and look at these factors. So we say that there are 3 methods. So in our book, right? There are 3 what? There are 3 methods. There are 3 methods by which it is transferred. By which it is transferred. There are 3 methods by which heat is transferred. So namely, Roman number 1, Roman number 2, Roman number 3. And members, I'm not going to give you the definitions of these methods. You are the ones who are going to find out the definitions. So let us look at, we have conduction, we have convection, and the third one is radiation. Third one is radiation. Okay, now here they are showing you a saucepan here, and here they can give you different they can show you how this methods happen during the heat transfer. So we can do that small diagram there, because these are our notes, this is our book. So you can do whatever you want, but for you to understand very well. And don't draw for me a yam. Sean.
Yes, teacher.
You must draw good diagrams, okay?
Yes.
Don't draw funny diagrams. And then you say, hey. Now Ruth is there laughing. Ruth, I'm very dangerous. Don't joke, okay? So here we have fire. Yes. So maybe as just a moment, finish up that diagram. And when we come back, we are going to start the second session, okay? So finish up the diagram.